or at least try to upsolve. Okay, let me share my screen. I hope you can see my screen and my audio is visible. My audio is audible. My screen is visible and audio is audible, right? Can I get thumbs up? Okay. So let's start. We have our first question, that is destroying towers. So let's read the question. Quack the duck has returned to his homeland and found N tower standing in a line. The height of the ith tower is AI. He wants vengeance for the destruction of his ecosystem and has vowed to wreak as much havoc as possible with his laser gun. Quack will operate on each tower exactly once in order he chooses. The operation on Tower I is as follows. Quack climbs the top of Tower I, shoots a laser to the right, cutting the first taller tower it hits to the same height as Tower I. Formally, let J be the smallest index such that J is greater than I and AJ is greater than AI, where AI and AJ are the current heights of the towers. If such J exists, then AJ is replaced with AI, otherwise nothing happens. So I hope you understood the questions. If not, let me explain. So we need to find the minimum possible final sum of tower heights over all possible orders of operations. So basically the question is, you are given an array and that represents the height of each tower. Now what we need to do is, for any chosen index I, we'll climb at the tower, like we'll reach that height and we'll look at our right. So any tower and we'll shoot a gun. So any tower in our right which has height more than the height of the current tower, that tower's height will be reduced to our current tower height, and we'll do this thing continuously until we find the height of the tower such that the sum of height of all the towers is minimum. Now, how will we do this? Let me show you a dry run. So first, we have an array which represents the height of towers. Now, height of the first tower is 4, second tower is 1, third tower is 3, fourth is 5, and fifth is 2. Now, what will we do is, since we need to find the minimum height sum of the towers, so we will try that every time we are shooting a tower, we want it to reduce to the minimum possible value that is possible. So what will we do is, we'll iterate through the array and we'll maintain a prefix minimum kind of thing. So that will contain the minimum height we have seen till now, and for next towers we can reduce all the next towers to to maximum that height. Are you able to understand? So let me just do this dry run. So for the first index, we have the height of the tower is 4. Now minimum till this height, minimum till now we have seen is 4. For the second tower we have height is 1, minimum till now is 1. Now for the third tower, we have height is 3 and minimum till now is 1. So what we can do is, when you are currently standing at the tower of height 1, we can stand at the top of this tower and we can shoot the tower 3 and we can reduce its height to 1. Now we'll go to index 4. We have tower of height 5. Now if I am standing at 5, can I shoot any tower in my right? No, obviously no. And since 5 is already reduced to 1, because 5 we have already reduced to 1 when you are standing at 3. Now 5 is reduced to 1. So can we shoot the tower 2? Yes, obviously. So we can reduce the tower height of 2 to 1. So what we are basically doing is, we are iterating through the array and we are calculating the prefix minimum. So up to a certain index I, if the minimum value seen up till that index is suppose x, then any tower in the right cannot have height greater than x, because I will stand at that particular tower and will shoot on all the towers on the right of that, right? So every tower that is of height greater than my current in height of index, that will already be reduced to the current will be the next prefix minimum. Like that, from that tower I can stand and reduce all the heights of the tower to the right of that. So let me just again write on this. So for the first index we are reaching is, we have the height of the tower as 4. So we'll stand at this tower and we'll look at our right. Can we fix, do you have any tower that is greater than the height of this? So we'll take the minimum. So probably for now we can only reduce 5 to 4, right? But let's continue to the next index. So here we have height as 1. So this is the minimum till now. So for every other tower in the right, we can reduce it to 1. Obviously, because if we are standing at 1, we can reduce this height 3 to 1, we can reduce it height 5 to 1, we can reduce this 2 to 1 as well. So now we are going to 3. Now 3 is already converted to 1, so we'll add 1 for this. Now I'll go to 5. Now 5 is already converted to 1, so we'll add 1 for this. Now we'll go to 2. 2 is already converted to 1, so we'll add. So for every index we'll just calculate the minimum value. Now up till up till a certain index, if the minimum value is something, then any index in the right of that index cannot have a height greater than that index. I hope I can understand, make you understand. So the another example is 1, 3 and 5. So here let me see the minimum. So when I'm standing at this current tower, I can make this tower 1, I can also make this tower to 1. Now when I'm going till this index, it is already converted to 1, so I'll add it to our sum. Now when I'm going to 5, it is already converted to 1, so I'll add it to our sum. So basically our answer is 3. So what I'm explaining again, what I am doing is, I am iterating through the array. At every index I am calculating the prefix minimum up till that index, and we are adding that to our sum. Now for 4, up to this index, the minimum height we have seen is 4, so we'll add 4 to our answer. When you are reaching this index, the minimum till this index is 1, so we will add 1 to our answer. When I'm reaching this index, the minimum till this index is 1, so I'll add 1 to our answer. Now we are reaching this index, the minimum till this index is 1, so we'll add 1 to our answer. And then we'll reach this index, the minimum till this index is 1. So basically we need to calculate the prefix minimum for every index, and we'll add that value to our answer, and that will be our answer. So the time complexity is big of n. I hope everybody can understand. Anybody has any doubt? Okay, I'm assuming that nobody has any doubt. So I'm moving on to the next question. So the next question is annoying the ghost. Ja the ghost is playing with rubber ducks. He has n piles of rubber ducks arranged in a row, but the ith pile contains AI ducks. Quack the duck gives J a strictly increasing sequence B1, B2, B3 till Bn, and commands him to make the piles A1, A2, A3 to An become exactly this sequence. Now, what are the two operations he can perform to make the sequence A to sequence B is, J may add any number of ducks to each pile, and J may repeatedly swap adjacent values. So now we have to, what we need to find is process. A process is called valid if after both stages the end sequence is exactly the sequence B. Now after this we need to return the minimum possible operations performed in the second stage. What is the second stage operation? That we need to swap adjacent piles, and if there is no valid process, so we need to output -1. So basically we are given a sequence A and we are given a sequence B. The sequence B is already sorted in increasing order, and we need to convert sequence A to sequence B by two possible operations. One operation is, I can add any number X to AI and convert it to BI, or else I can swap any two index AI and AI plus 1, any two adjacent index I can swap, and then I can convert it to B. So I need to find the minimum possible operations for the second operation. Like I can add an X any number of times, but I don't need to count that. I only need to count how many swaps do I need to convert A to B. Now, what will you do is, first let me give you an example. So suppose, okay, so first let me give you one example, that is one, suppose 3 1 2. Now we have this array. Now we need to calculate the number of adjacent swaps to make this array increasing. Now first we will calculate the number of inversions. Now what are the number of what is inversion means? That ai is greater than ai plus 1. Since I need this array to be sorted in ascending order, I'll count the number of inversions. Now first inversion is 3 and 1. Since 3 is greater than 1, number of inversion is 1. Now 3 and 2, 3 is greater than 2, so number of inversion is again 1. Now for 1 and 2, 1 is less than 2, so I don't need any inversions, right? Like this part is already sorted. For 3, 3 and 1 is one inversion, and 3 and 2 is one inversion. Now if I want to sort this array with just adjacent swaps, how many swaps do I need? First I will swap 1 and 3. So 1 and 3 are swapped, and then I have 2. Now I will swap 2 and 3. So I'll have 1, 2, 3. So see, we needed 2 swaps. So can you observe one thing, that number of swaps is equals to number of inversions. So this is the concept that we are going to use in this. So for calculating adjacent swaps, we just need to calculate how many inversions are there. So now what the question is, I am given a sorted array B, and I need to convert an array A to array B by 2 possible operations. Now what is the idea? The idea is basically greedy. So let me just go through the algorithm, and then I'll explain the intuition behind that. So first, suppose we are given an array A, that is 2 to 1, and we are given an array B, that is 1 to 3. So we'll have a used array separately, and we'll have a position array for storing the positions. Now what we will do is, we'll iterate through each and every element of B, and for each element of B, we'll iterate through the array A. Now how are we doing this? First we are going to the okay, so see, this is the array A and this is array B. So initially we have a used array initialized to 0, and we have a position array where every position is marked as -1. Now we'll iterate through every element of B. Suppose for j equals to 0, j is less than size of B, j plus plus, we are iterating through every elements of B. So j is 0, b0 is 1. Now for this element of B, we'll iterate through each of the elements in A. Now first, and we'll check if that element of A is less than or equal to my current B's element. So first ai is 0. So for I equals to 0, ai is 2. Is 2 less than equals to 1? No. So I'll move to the next element. Now for I equals to 1, ai is 2. Again, 2 is not less than equals 1, so we'll move to the next element. Now for I equals to 2, we have our used array and our position array. So used array marks that this particular element of array A is used, and which index does it points to? It points to the 0th index of B. Like this element of A matches with the 0th element of B. So we are marking the position as 0. Now we'll move to j equals to 1. That is, for bj is 2. So we have the next element as 2. Now for 2, we'll again iterate through every element of A. Now the first element of A is 2. Now is 2 is less than equals to 2? Yes. So we got our index. So we'll now update our used array. For used array, for which element we got we used this array element, so we'll mark used of this index as 1. And to which index of B did it get marked to? So for index 1 of B, we mark this index of A. So we'll mark this as 1. Now for j equals 2, we have B of 2 as 3. So let me just copy this. So for now we have j equals 2. So the B of 2 is 3. Now for 3, we'll check for each of the elements of A, and we'll check if the value of that index of A is less than equals to B or not, and also it should not be used. So we are going to the first element of A. So first element of A is 2. 2 is less than equals to 3, so obviously the condition satisfies, so we can take this value. But since this I equals to 0 is already used, see, our used array is already marked 1. So we used array is already marked 1, so it means we have already taken that value, so we can't take that value again. So I'm moving to the next index, that is I equals 1. Now I equals 1 is 2. 2 is less than equals to 3. Yes. Is it already used? No. So of course we got our position 2 for array of 2. So for B of 2, so we got our position of for this element, we are marking this array value to B of 2. So we'll update the position to 2, and we'll mark the used array to 1. Now we'll count the number of inversions. Now why are we counting the number of inversions? Because we need to find the number of adjacent swaps. So I just told you that the number of adjacent swaps is just equals to the number of inversions, right? So the position array is 1, 2 and 0. Now we'll run a big of n square loop through the position array, and every time we get an inversion, we'll increase our count, and that count will be our answer. So for 0 and 1, see, this is already sorted, so there is no inversion. Next for 1 and 0, this is 1 inversion, and for 2 and 0, this is another inversion. So the total number of inversions is 2. So our answer is 2. Now you might have a few questions, how is this working, what is the intuition, and whatever. So see, basically we are approaching this question greedily. So what we are doing is, for every element of B, we are trying to find an element of A which is less than equals to B, but at the same time we want the element of A to be as left as possible. Because see, for this element of B, we can take these two or these two, but when you are finding the first two, we are breaking off. Why we are breaking off? Because we need the minimum positions. Now why do we need the minimum position? Because if we store the minimum position, it is eventually going to reduce the number of swaps. Now how is this going to reduce? So see, suppose when you are processing the array B, let L be the first index where A of L is less than equals to B, and there exists a R greater than L where A of R is also less than equals B, but we are taking the L index, right? We are taking the first index and then breaking off. Why we are doing this? Suppose we have taken R instead of L, we have not breaked off when you got our first index less than equals to B. We have continued and we have taken any index after that. So what will happen? Then we will have to mark position of R as J and position of C. Then we have to mark position of R as J, right? Because J is the iterator which we are using to iterate through B. Now for any J, we are marking the position of I. Now when we are and also AR is less than equals to B of J, then we are marking the position of R as J, right? So since L is less than equals R, so when we are counting the inversion, we are going like from I equals to 0 to N, and from J equals to I plus 1 to N. So we are counting the inversions, right? So since L is less than R, so when we will iterate through the array, so L and R will become an inversion, which we don't want. We want to minimize the number of inversions. That's why we are taking the first possible value that matches AI is less than equals to bi. So what we are doing mainly is we are greedily finding the value of AI which is less than equals to bi, or more precisely we are trying to find the value of AI which is less than equals to bi, and also that AI must appear the very first, like the first AI that is less than equals to bi we need to found, because then we will assign the positions in such a way that that it will reduce the number of inversions, and eventually it will reduce the number of swaps. So I hope you can understand, and if not then I'll re-explain. I hope you understand.
Didi, I have a question. Like, maybe use bubble sorting algorithm here.
Like how?
Um, like first, like just I have tried to solve it with brute force, like yesterday. Okay, and half of my problem was solved. Like mostly was correct, but in one case only there was a problem, slight problem. That's why I was asking.
So how did you do it?
I have done it like the number of times let there be a one variable, okay, and the number of times it will go, then the C will increase. Let C be equal to 0, and the number of time the swap will happen, then it will increase one count, C plus plus, something like
Like
that.
first you have sorted the array A.
Yeah, yeah. First, I will sort it directly.
So did so it was failing na, any test case.
Uh, like in second last case, I guess it was failing only. In most of the cases, it was okay. So I thought there was a problem there. That's why I was asking.
So let me check.
Yes,
So for this case it was failing, right?
yes, yes.
Okay. So what you did is first this is the array A and this is array B. So you sorted A. So that means 1, and here it is already 2. So it should. Then how did you calculate the number of swaps?
Like just in case of bubble sort, uh, see the same array I have to swap the matlab A array, the
Hmm.
first array, the number of times
Yes.
it will get a swap to make it sorted
Okay.
with the help of bubble sort swapping.
Okay. But have you taken, like you have only taken in consideration that you are just swapping the values. So there might be cases where you don't have to swap the values and you can just increase it a certain with a certain value x, and then you can not count in that in our operation, right? So you need to do it such that in a optimized way you need to do this. Like we have to do this such that we can reduce the minimum number of swaps, so we can obviously swap all the values and sort it, so that, but that will increase the count of swaps, right? So we need to keep in mind that at the same time we need to minimize our swaps. So if it is possible to increase the value and not swap, so we'll do that, right?
Okay, like
So you are basically not taking into consideration the fact that we can increase the value of a thing without just swapping.
that I am getting it. So
Yes. So yes.
so I was trying to ask, like, maybe go with bubble sort, and like, can we do the optimization around it to
No,
increase?
see, what are you trying to basically do is you are doing a bubble sort, and every time you see a inversion, so you are just adding that value to count, right? But approach, the approach I told you, since I am checking for all AI which is less than equals to bi, and also I am checking for the first index of that AI. So in this case I'm already considering the fact that if my current index is already less than equals to AI, then I am not counting any more swaps. Like just I just told you that I'm doing the first AI which is less than equals to biy, so that I am reducing the number of swaps. If I do the last AI, which is less than equals to BI, that will eventually increase my number of swaps. So in this case, I'm also considering the fact that suppose J is the index of B, and my AJ is already less than equals to BJ. So I'm not going to take that, right? Like for swapping. I hope
हाँ
I
दीदी.
can to understand. Like, see, so for every element in B, I am trying to find the element A which is less than equals to B. But at the same time, I am trying to get the element A which appears first. Now, why I am taking this appears first? This is the point I am taking into consideration, that I am trying to minimize the number of swaps. So in case I am taking any element that is greater, that has index more than this, then the number of inversions will eventually increase, that I don't want. So I am taking into consideration the fact that I am reducing the number of swaps, so that's why I am taking the first AI which is less than equals to bi, and in this condition only I am also eliminating all those swaps where I can just add a value x. So in the bubble sort thing that you are doing is you are just counting the number of swaps, but you need to greedily find the AI which is less than equals bi, so that we can minimize the number of swaps. And also in our mind we have the thing that, okay, if I am going to increase this AI value by x, I don't need any further swaps, but at the same time if I need any swap, I am going to minimize the number of swaps, right? So I hope you are getting the intuition somewhat. You can just dry run and check.
Okay दीदी. Once I will try, then I will inform. Thank you.
Yeah, like overall you got the intuition somewhat, right? Like for every bi, I am trying to search AI which is less than equals bi, and since we are counting the positions, right, we are counting the inversions or positions, so we are taking the first position of AI, first position I, where AI is less than equals bi. Now this position thing is very important. Since we are taking the first position, that's why we are reducing the number of swaps. So just for reducing the number of swaps part, just check this part of the solution intuition clearly, that why are we taking the first AI which is less than equals bi? That is the condition that is ensuring that we are reducing the number of swaps, and at the same time we are eliminating those swaps where we can just increase the value by x. Like you got the algorithm, right, how it works. And
Yes दीदी. Okay. Like, I can get it kind of intuitively. So I will solve and then inform you.
okay. Now moving on to the next question, that is, so duck surplus. So Jay the host is playing with rubber ducks again. There are n piles of rubber ducks arranged in a row from left to right. Initially, the ith pile contains AI rubber ducks. While the sequence A is not sorted in non-decreasing order, Jay must perform the following operation. Choose two adjacent piles such that the left pile contains more ducks than the right pile. J swaps these two piles and then adds the number of ducks in the new left pile to the new right pile. Formally, choose an index I such that I is less than n and AI is greater than AI plus 1. Then replace the adjacent pair with first we need to do is we have two adjacent values AI and AI plus 1. Now if AI is greater than AI plus 1, we'll first swap these values, that AI plus 1 and AI, and then add AI plus 1 with the last value. So we are swapping first and then adding AI with the last value, that is AI plus 1. Now, for example, if we have two adjacent piles, 7 and 3 rubber ducks, then after the operation, they will contain 3 and 10. So I hope you can understand that we are swapping. This portion becomes 3, this portion becomes 7, and then we are adding 3 with 7. So it becomes 3 and 10. Now, J may choose any index satisfying the condition above step. It can be shown that regardless of his choices, the process eventually ends with the sequence sorted in non-decreasing order. J wants the largest pile at the end because of the process to contain as few rubber ducks as possible. Determine the minimum possible value of the largest pile. So basically what we need to do is for every value of AI and AI plus 1, where AI is greater than AI plus 1, we need to swap it, and then we need to add AI with AI plus 1, and then we need to do this continuously such that the array becomes sorted in non-decreasing order, and then we need to return the value of the last index, like the largest value of that array. So let's see how it is done. So do we need to actually calculate, sort the array and then find the last index? We need to actually swap them and then add the value and then keep the array and check if the array is sorted and then find the last value? No, we just basically need the last value. So we can just do this continuously and reorganize the array in such a way that it is already sorted. I just need the last value. So I will go through the dry run and I'll make you understand how we are just keeping in track what will be our last value, and not we are not rearranging the array. So basically, whenever I am getting a AI and AI plus 1, where AI is less than AI plus 1, so what is the largest value when we are swapping and doing the whole operation? See, we are swapping them and then we are adding AI plus 1 and AI and putting it in the last index, right? So the largest value is this one. Till that point the largest value is AI and AI plus 1. So I just need to keep track of the largest value. I don't need to actually keep my AI and like actually sort the array and rearrange the array. So I'll just keep the track of the largest value every time I am doing this operation. So what I'm doing is this intuition is kind of like a stack. So I'll just whenever I see any index AI greater than AI plus 1, I'll basically store my last index. We'll keep in mind that what is the largest value I'm seeing till this index. So let's see, this is, suppose this is our array, and what we need to do this, every time we see any inversion, we just need to swap them, add AI to the say AI plus 1, and then we need to sort this array, perform this operation as number of times as possible so that the array gets sorted, and we need to return the maximum value. So initially answer is 0. So we'll keep this answer array for storing our largest value. This answer array is not the array A sorted in ascending order. We are not rearranging the array. This answer array is basically storing the largest value in every index. So first we have 3. So we'll just insert 3. Do we have any index before 3 that is greater than 3? No. So we'll just store 3. Now we have 1. Now see, we have 3 which is already greater than 1. So what we'll do is, for 3 and 1, we can just swap them, make 1 and 3, and we'll add 1 to 3. So the final thing will become 1 comma 4. So the largest value we are seeing is 4. So what we'll do here is, since 3 is greater than 1 and the maximum value we'll get from this is 4, now we'll pop back both of this and store 4. So till now the largest value we saw is 4. Now we have 4. So since 4 is greater than equals to, so this is not, this 4 is less than equals to 4, so it's obviously not an issue because this array is already non-decreasing order. Now we have 2. Now for 2, what are they doing? See, 4 and 2, this is one inversion. Since 4 is greater than 2, what we'll do, we'll swap them, so it will become 2 and 4. Now we'll add 2 to 4, so it will become 2 and 6. So I'll just put 6. So I'll pop this 4 and 2 and I'll put 6. So this becomes 4 and 6. Now again this is another inversion, so we'll perform the operation. So what will be the operation? That is 6 comma 4. Now I am adding 6 to 4, so it will become 6 comma 10. So basically the okay, yeah, so since 4 is since 4 is already less than 6, so the array is already in sorted order, so we don't need to do any further operation. So the final value is 6. That is the last element of our answer. So I hope you can understand. Let us take another dry run. So this is 3 2 1. Now first element is 3. We have no elements before 3. We'll just insert 3. Now we have 2. Now after 3, we are pushing 2. Now see, 3 is greater than 2. So the array is, so this is one of the inversions. So after we perform our operation, what is the maximum value we'll get? That is 5. 3 plus 2. So we'll pop this both of these elements and we will push 5 to our array. Now we have to insert 1. Now after we insert 1, see, again this is an inversion. So what we'll do, we'll pop both of these value and we'll push the largest value after the operation, that is 6. So we'll push 6 in our array. Now only one element is left in our array, so the answer is 6. I hope you can understand. So basically we need to keep track of the largest value in our array. We don't actually need to sort the array in ascending order by performing this operation. We just need to keep track that we need to find the largest value. So what we'll do is, basically we'll iterate through the array, and every time we'll see an inversion, what we'll do is, we'll pop back the last two elements and we will push back ai and ai plus ai plus 1. Now again we'll do this till the inversion is not gone. So we'll need a while loop for that. Don't do if, right? I should show my solution. So see, we are iterating through the array. Now we are pushing the element. Now while our size is greater than equals to, what are you doing is, if ai is greater than ai plus 1, so we'll get our element and then we'll pop back our element and then we'll add the element to our answer of back. So I hope you can understand, right? I told that we are popping back two elements, so we don't need to actually pop back two elements. We can just pop back one element and add that element to our already present last element. So it is basically the same thing. You can just pop two elements and then add their sum, or you can just pop one element and add its sum to the last element. So finally whatever will be the last element of our answer array, that will be the largest value possible. And in this process we are already sorting. I hope you can understand that we are already sorting, because every time we do the operation, the last value is getting increased, so we need to check for further values in the right, because the previous values are already sorted, right? So we just need to check for the last value. So iterating in the forward direction, we are checking for all values. So eventually the array is getting sorted only, but we are not actually keep storing the array and sorting it physically, but we are just keeping in track the maximum value that is possible. So I hope you can understand. Yeah. Okay, I think this is clear. So anybody, if anyone has any doubt, can ask. Or else you can leave the meet.